Okay, so this one is going to be for truth tables, and in being for truth tables, I'm going to do a few basic ones where we have to ask about consistency and determine is it a tautology, inconsistent, or contingent. So let's start with something simple. Let's start with P arrow P. To assess P arrow P, let's see. I guess I can't mess with that one. So to assess P arrow P, we can start with just P over here. Make that a little bit bolder. And then we want to know what P arrow P is. So we put in our truth values here, true and false, plug them in, and we ask, what's T arrow T? It's true. What's F arrow F? It's true. Since we have all true statements here, that means that this argument is, in this case, both consistent and a tautology. And since I don't want to have to rewrite these things every single time, I'm just going to be using the exact same thing. So let's see what would happen if I had something that looked a little bit different. So let's ask what would happen if I had P, therefore not P. Again, we would plug everything in first. T, F, T, F. We flip this P over here to F and T. And then under the main operator, we would write false and true. Since we have something that is sometimes true and sometimes false, this is consistent, but it's contingent. So let's go on to the next one. Let's say that we had negation of P arrow P. We would plug everything in first, find out that this is always true, and then we would have to negate it. So that turns into false and false. Since it's false all the time, this is inconsistent. So for the next one, we're going to need additional letter space. So I'm just going to rewrite some of this real fast. Let's say that we have... There, that's close enough. One there, one there. So this is going to be 2 letters. It's going to be... add the break there. It's going to be not P, therefore P arrow Q. So we need a P column and a Q column. So 2 T's and 2 F's, then alternate T's and F's. Then we're going to write everything in under the operators. Then we're going to start solving. We're going to solve this parentheses first over here. That's true, false, true, true. Then we're going to do the negation. False, false, true, true. Then we ask, do we ever have a situation where it's T arrow F? The answer is no. In this case, it is T all the way down, which means that this is a consistency and a tautology. So the next one is a little bit longer. It's P, double arrow Q. Then it's double arrow, negation, P, double arrow, negation, Q. So note that our main operator is right here. Repeat, our main operator's this column right here. But let's go ahead and fill things in. So even though this is a more complicated truth table, what you're going to be doing is you're going to be taking the values from our reference column and plugging them as you go. And then when it comes to solving, we're going to start solving by looking at the inner parentheses. In this case, start with the inner parentheses on the left. If they match, it's true. If they don't match, it's false. Move to the parentheses on the right. Note that you have to do the negation first. Then do the double or the biconditional. And then you're going to hop outside and do the negation of the biconditional. Now we're going to compare these two lines right here, this column and this column. If they match, then it's true. If they don't match, it's false. So since they match all the way down, actually I take that back. Nope, they do match all the way down. This is a tautology and it's consistent. What I'm going to end with is I'm going to end with a 3-letter truth table. Since 3 letters is likely to be what we give you on the exam, these are all basic truth tables. Everything that I've given you so far has been 2-letter truth tables, but it's very likely that you're going to get a 3-letter one on the exam. So we might as well practice it.
Have a good night.
Yeah, I'm just going to have to redraw this one. Please hold. Let's quickly redraw this just to be able to incorporate a 3-letter truth table. And let's solve for this problem. P and Q, arrow R, arrow, P, arrow R, and Q, arrow R. So the main operator here is going to be this arrow. But let's go ahead and add in some columns so we can see what's going on. They aren't as nice as what we had earlier because I don't want to use the ruler tool, but they're approximate. And that should work. And now we want to go ahead and plug in the values under the letters. Now that we've plugged in all the values, we can go ahead and start solving. So let's solve for all the parentheses first. For an and statement to be true, both things have to be true. So those things are true and everything else is false. Arrows, everything but T arrow F is true. Now solve for the submain operators. Again, everything but T arrow F is true. So that means that this is true all the way down. For an and statement, they both have to be true at the same time. So that one's true, that one's false, that's true, that's false, that's true, false, true, and true. We're going to compare the orange columns now to get our answer. For arrow, we want everything except true, arrow, false. So since there's an F there, it's false. False. And in this case, what we find is we have a mixture of T's and F's, so this is going to be consistent, but it's going to be contingent. So for this video, I did longhand truth tables, and this was to evaluate consistency with respect to tautology, inconsistency, or contingency. In the next video, I'm going to do shorthand truth tables.